An animal in the North Pacific has no bones, no shell, no armor of any kind. Its body is 90% soft tissue. A gap the size of its beak allows it to push through. One rigid structure inside its body is the beak. Everything else is muscle, skin, and water.
Carrying coconut shells as portable shelter. Recognizing individual human faces.
Not approximately, exactly. Researchers have found octopuses invisible from 30 centimeters away. This animal lives for 5 years, sometimes 4, sometimes 3. In those 5 years, it goes from the size of a grain of rice to the size of a small car. It solves problems no invertebrate should be able to solve. It fights sharks, eels, seals, and wins some of those fights. Then it reproduces once, just once, and dies. Every time, without exception. Built for one run. No second chances, no lessons passed forward. This is the full life of the giant Pacific octopus. 5 years that are stranger than most lives.
That last 50. Size of a grain of rice. Already alone, it begins in a cave.
The female laid between 50,000 and 100,000 eggs. She attached each cluster to the cave ceiling herself, strand by strand, over several days. Then she stopped eating. She will not eat again.
For the next 6 to 7 months, she stays in the cave, aerating the eggs constantly with her siphon.
Cleaning them with her arms, defending them from anything that approaches. She loses body mass every week. By the time the eggs hatch, she is a fraction of what she was. When the eggs hatch, the paralarvae are 3 millimeters long, the size of a grain of rice. With 8 arms already working, they drift upward immediately, away from the seafloor into open water. The first weeks of their lives, plankton. Invisible, carried by currents, eating whatever microscopic organisms they can catch. The female watches them go. Then she dies. Not exactly from starvation, a biological process called senescence begins at fertilization and cannot be stopped. Her optic glands start secreting hormones that shut down her body systems one by one. From the moment the eggs are laid, she's already gone before the eggs hatch. The body is the last thing to know it. Of 50,000 to 100,000 eggs laid, roughly 2 will survive to adulthood. Not 2%. 2. The rest are eaten by fish, jellyfish, filter feeders. By the plain indifference of open water. After 3 months drifting, the survivors settle. They sink back to the seafloor, find a crack in rock, and go inside. At this point, they weigh about 5 grams, the size of a strawberry, and something changes. On the seafloor with rock around it and a den to defend, the common octopus stops being prey. It starts figuring out how to be something else. 1% of body weight, every day. A subadult giant Pacific octopus gains 1% of its body weight every day.
5 grams becomes 50 inches months.
5 kilograms becomes 50. The largest confirmed specimen weighed 71 kilograms with a 9-meter arm span. To get there, it ate constantly. Crabs, shrimp, clams, scallops, lobsters, abalone, fish, whatever lived on the seafloor and could be caught. It hunts at night. 8 arms across the reef, probing crevices with arm tips that taste what they touch. chemoreceptors in the suckers, functioning like a tongue pressed directly against a surface. It doesn't just feel the crab under the rock, it tastes that the crab is there. The den is the center of everything. The octopus clears debris, rearranges rocks at the entrance, piles empty shells outside. That midden grows over months into a record of everything the animal has eaten. Researchers have excavated dens containing hundreds of crab shells, bivalve fragments, fish bones.
A full feeding history left at the door.
Lab studies show giant Pacific octopuses learn maze routes after a single trial.
And remember the solution for weeks. They recognize individual human researchers by face, responding differently to familiar people versus strangers wearing identical uniforms. They carry rocks to block den entrances. They transport coconut shell halves across the seafloor to use as portable shelter. 2/3 of the octopus's neurons are not in its central brain, they're in its arms. Each arm processes information on its own. The octopus doesn't just think, it thinks in 8 places at once.
But the intelligence has one hard limit. It goes nowhere.
No accumulated knowledge passed down. Every octopus solves the same problems from scratch, alone, in the same few years, and takes everything it learned into the grave with it. The most cognitively complex invertebrate on Earth. And every generation starts from zero. The ambush. Zero distance.
In 2000, the Seattle Aquarium put a giant Pacific octopus in a tank with several dogfish sharks.
The tank was large, the sharks were fed, and staff expected the 2 species to leave each other alone. Shark carcasses started appearing on the tank floor. Nobody saw it happen during the day. Night vision cameras caught it. The Octopus waiting, motionless, until a shark passed close. Then, in under 2 seconds, all 8 arms out. The giant Pacific octopus wrapped around the shark completely, arms holding its gill slits closed. The shark couldn't breathe. A few minutes. The blue-ringed octopus dragged the carcass to its den. In the wild, shark remains turn up in blue-ringed octopus middens. This isn't a regular predator-prey relationship. It's opportunism. A shark that passes too close at night, small enough, that doesn't register the octopus as a threat. Because the Octopus looks exactly like the rock it's sitting on. The shark's mistake is always the same. It doesn't see the attack coming. No movement to track, no approach, no threat display. The Octopus was already there. It was there before the shark arrived. Outcome? Octopus wins. Same tactic it uses for crabs. Wait. Become the reef. Strike from zero distance. The den war. Arms for rent. The moray eel and the giant Pacific octopus want the same things. The same crevices, the same prey, the same spots on the reef. They are constant rivals.
Not occasional ones. The moray has a specific advantage. 2 sets of jaws.
The outer jaw grips. A second set, the pharyngeal jaw inside the throat, shoots forward to pull prey inward. An octopus arm caught in a moray's mouth doesn't come free easily. The footage exists from multiple locations. An octopus losing 1 or 2 arms in a moray's mouth, then jetting away in an ink cloud. The arm stays. The octopus escapes. This looks like a loss. It isn't quite. The arm grows back, full regeneration within weeks. The octopus traded tissue it can replace for its life.
The math works. The more important conflict is the den war.
Both species need rock crevices of specific dimensions. When an octopus finds a den occupied by a wolf eel,
which fills the same ecological role despite not being an eel, it doesn't always leave.
documented cases show octopuses forcibly evicting wolf eels, arms wrapped around the eel, pulling it out, then occupying the space, sometimes evicting a mated pair. Outcome: split. Open water. The eel's jaws are serious. The Octopus loses arms and runs. On the reef, fighting for a den, 8 arms against a long-bodied fish often evicts it.
In May 2012, a photographer documented something unexpected.
A giant Pacific octopus in shallow tidal water reached up, grabbed a seagull standing at the surface, and pulled it under. The bird drowned. The Octopus ate it. Not a fluke.
Multiple observations confirm the behavior. The Octopus waits below the surface until a bird steps close enough.
When speed cancels everything. 2 documented encounters. 2 seals. Same result. A fur seal in New Zealand in 2017. 120 kilograms. Fast. Built for exactly this. It grabbed the Octopus and spent several minutes at the surface thrashing it, spinning, breaking arms. Beating it against the water. The octopus lost. The second encounter off Vancouver Island. A harbor seal versus a giant Pacific octopus. Same outcome. All need the opponent to be still or slow. A seal neutralizes everything by staying in motion. The ink cloud works against slow, visually oriented predators. Against a seal hunting by echolocation. In murky water, it does nothing. Outcome: the seal wins. The ambush strategy needs the target to come close without knowing what it's approaching. Seals come fast. They already know exactly what they're hunting. Not a fight. This is not a fight. The sperm whale is 57 tons. The giant Pacific octopus at its largest is 71 kilograms.
The whale outweighs it by 800 to 1. The whale hunts by biosonar.
It maps everything on the seafloor with pulses of sound and reads the echoes. Density, shape, position. An Octopus pressed flat against rock, invisible to every visual predator on the reef, is not invisible to sonar. The whale reads its body. It knows what it is. It knows where it is. The Octopus, arms spread wide, goes in whole. The whale does not slow down. It does not adjust course. The giant Pacific octopus registers as a minor caloric input in a feeding run.
That will include dozens of other animals before the whale surfaces for air.
Ink doesn't work against sonar. Camouflage doesn't work against sonar.
The suction current pulls the octopus off the rock before the arms can grip anything.
Intelligence is not always the relevant variable. Sometimes the relevant variable is 57 tons. And a sonar system that sees through rock. Once. That's the whole deal.
The male has one modified arm, the third right, called the hectocotylus.
At maturity, it develops a groove along its length and a modified tip that transfers sperm.
During mating, this arm goes into the female's mantle cavity, and deposits a spermatophore near her oviducts.
The process takes several hours. The male knows the risk. Females eat males during mating. It's documented. Some males approach arm first at full extension, keeping the rest of the body as far back as possible.
Others complete the transfer and leave fast. The ones that stay too long sometimes don't leave.
After mating, the male stops eating. The hormonal shift triggered by sexual maturity starts shutting him down.
His behavior becomes disoriented. Within months, he's dead. The female finds a den. She lays her eggs. She seals herself in. 6 to 7 months. No food. The entire time, blowing water over the eggs to keep them oxygenated. Cleaning them, removing any organism that settles on the clutch. If something approaches the den entrance, she defends it. Arms spread wide, skin flushed dark. Late-stage brooding females lose the ability to change color. The skin settles into a dull, patchy reddish brown. The arms move slower each week.
She still responds to disturbances, but the responses get weaker.
Researchers who study octopuses describe watching this as one of the quieter, harder things in marine biology.
When the eggs hatch, she blows them out with pulses from her siphon.
Pushes the paralarvae into open water. Some researchers have observed females doing this, who could no longer hold their own arms up. She blows them out. Then she stops. 2 of the 50,000 will survive. The female dies in the den alone, as she was for almost everything before it. 5 years. Nothing carried forward.
5 years. In that time, 3 millimeters to 9 meter arm span. Problem solving that outperforms animals with 10 times the lifespan.
An intimate map of one stretch of seafloor. Fights won against sharks and birds.
Arms lost to eels, grown back. A den built, rebuilt, defended. Then reproduction.
Then death. No exception. The hormonal cascade that kills the octopus at reproduction is not a disease.
Or malfunction. It's the design. Resources that could have gone into a second lifespan go into egg production and brooding instead. Biologists call this semal parity. Putting everything into one reproductive event. Pacific salmon do it. Mayflies do it. The giant Pacific octopus, with its distributed 8-kilogram brain and its tool use and its face recognition, does it too. It is the most cognitively complex semilparous animal on Earth. It builds something extraordinary, runs it for 5 years.